Okay, so the problem is you have 2 coins. You have one that's a heads and a tail, and then one that's a heads and a heads. And what is the probability that I picked the fair coin, which is the heads and the tails, after flipping it twice and getting heads both times? So you'll make a tree diagram, and you'll do fair and not fair, and that's 50% each, so 1/2. For the fair, you want to get heads and heads, so it's 1/2 each. For not fair, it's probability of 100. So to figure out what fair is, you have to do 1/2 times 1/2 times 1/2, which equals 1/8. And then for not fair, you do 1/2 times a whole, which equals 1/2. And then you want to make it a common denominator, so you make it to 4/8. So then you want to get the probability of B given A, which will be equals probability of A and B over probability of A, which equals 1/8 over 5/8 equals 1/5, which equals 20% chance of picking the fair coin.
So next we're going to do a chart.
To win the game of dice, you must get a 6. So we created a chart, and how many ways can you win?
Well, there is 5 ways that you can get a 6 by rolling a dice, so 5 ways you can win.
What's the probability you roll 2 threes? Well, there's a 3. It's another 3. It's 1/5, because they meet in the middle.
And it's only once out of 5 times.
So this is a two-sided table, and the question is asking, or is saying that there's 30 students, 18 of them are boys and 12 of them are girls. The students are chosen at random to present his or her solution. 4 boys and 3 girls have already presented. So A is saying to create a two-way table. So for boys and girls, and then presented and not presented. There's 4 boys that have presented, 3 girls that have presented. There are 14 boys that haven't presented and 9 girls that have not presented. You would then add up the numbers in each of the columns to then get what this number of each of these columns would be, which is 30. B says sometimes two-way tables have probabilities for entries instead of counts to make it easier to solve problems. Make a new two-way table, but this time use probabilities instead of counts. So for this, you would, for boys, or this should be switched, but for girls it's 3 out of 30, which is 10, and then boys is 4 out of 30 in the presented, which is 13. And then for C, they're asking to find the probability that boys, a boy who has already presented was selected, which there are 4 boys that have already presented, and there's 30 students in total, so that'd be 4 out of 30 that would be selected to present. And for D, the probability of girls or the students that have presented. So there are there's 9 girls that have not presented and 7 that have already presented. So that's 16 in total out of 30 out of all of the students. And then for E, you would use the equation probability of girls given P, the students that have already presented, which would be 3 out of 7, because you would take the girls and put it on top, and then divide that by the the entire number of students that have already presented.